How many people have not heard of I2B2 before today? I know you're shy. I know there's a lot of people here that have not heard of it before. I'll give kind of the very quick intro to it because it's going to be relevant here. We're talking about the MassCPR Federated Data Network. And some acknowledgments and disclosures. So the Massachusetts Consortium in Pathogen Readiness, or MassCPR, this was formed in early 2020 to address the COVID-19 pandemic. It's now expanded out to other pathogens and infectious diseases, particularly with pandemic potential. It was organized by Harvard Medical School, but along with many other hospitals and medical research centers in Massachusetts. Also, key partners in this are the Massachusetts Department of Public Health. We had the commissioner last year come and give a keynote at this conference as this project was first launching. And the Boston Public Health Commission, and also the CDC has interest in this project as well. Consortium was really about helping organize, particularly cross institution research related to infectious diseases and COVID. They had donor money and used that to fund over 100 small pilot projects that had over 1,000 publications that came out of that. They have a number of different areas of focus, including surveillance, epidemiology, diagnostics, and others. Today, they're largely focused on two areas, biospecimens and a data network. One of the things they facilitated during the pandemic was one institution might need biospecimens that only exist in another hospital. So they would manually call up those hospitals, try to find those biospecimens, and facilitate that transfer, as well as with data. Someone would manually pull out a data set and send that over to the other hospital where the study was being done. This worked well because it was able to actually facilitate collaborations, but it was very inefficient and used a lot of manual effort in there. So technologies like the ones at this conference, I2B2 and Shrine, are a way that a lot of this can be automated and turns into self-service tools so we can expand beyond just these limited number of funded projects and allow any investigator to do similar kinds of research. So that's the data network part of it that I'm helping lead. Another key component of MassCPR is they do a lot of workshops, outreach, seminars. So it's about dissemination, helping build awareness of these types of tools. So we're building this proposed MassCPR federated data network that will allow investigators to log onto a website and be able to query across these different institutions and conduct MassCPR-like studies for infectious disease research and public health use cases. There are two tools that are part of this, I2B2 and Shrine. I2B2 is a number of different things. It's a common data model, so your institution can pull lots of different kinds of data, electronic health records, biospecimens, others into it. There's also a user-friendly website that fits on top of it. So investigators, without needing to know details of large language models, computed phenotypes, SQL, they can just drag and drop in what kind of information they need about those patients. They press a button and they get a count of how many patients meet their criteria. You can get breakdowns and visualizations to learn more about those cohorts. And then with IRB approval, you can extract patient-level data for further analyses. This all happens within your institution behind the firewall. Shrine, which is a shared health research information network, that's a federated tool which takes a user's query and broadcasts that out to lots of different I2B2 sites or OMOP or eventually others that can run the queries locally and return the summary information back to investigators. So Sean was talking about the ENACT network that's built on that Shrine federated network software where most of the sites at the endpoints are running I2B2 databases and some as well as OMOP. So in this federated network, on the left-hand side are the individual data sets that are plugging into this. And these are being loaded into mostly I2B2 and also some OMOP sites. So all the electronic health record from Beth Israel Lahey and Mass General Brigham and one of the Harvard-affiliated institutions. And then after that, Boston Medical and UMass or other hospitals. Then there's public health data that's the Massachusetts Department of Public Health and the Boston Public Health Commission are contributing to this. Initially, it's aggregate information like wastewater counts, but then there are also patient-level data sets which are being explored. And then the biospecimen information. There's a MassCPR biospecimens program where there are freezers that have actual specimens in there, and then the metadata about those specimens is stored in REDCap databases. And that REDCap information can flow into I2B2 and make it queryable both within I2B2 and in Shrine. So all those different kinds of data will be plugged into this Shrine network, and then users can use it for a variety of applications, including real-time infectious disease surveillance. The real-time is important here. As a federated network, you're not waiting for hospitals to send their data into a central database, which can get old over time. The infectious disease use cases really need up-to-date information, and being able to query directly into the hospital's I2B2 systems get you more recent data than what you would get if that data was pulled into a central location. It's also used for clinical trial preparation if you want to do a multi-site study, finding where the patients are located. Pharmacovigilance, tracking patients who had vaccines or other treatments to see what happens to them over time. The data is somewhat unlimited. You can keep giving lots of people data sets, but the biospecimens are a limited resource. So they're going to use this network to help people request specimens and then go through a process where committees can figure out how to best allocate that. An important part of that is comparing the small number of patients who have biospecimens to the much larger number of patients who have electronic health record data. For example, are the specimens you have on influenza at your institution representative of the patient population of the larger population of the hospital? And that will help them determine which studies are more appropriate for the limited resource of specimens. And then the goal of all of this is to improve pathogen readiness, is why MassCPR is funding this network development. The hospitals that are part of this are reviewing the governance documents right now, and it's always fun having the lawyers try to figure out what kind of queries we're allowed to do or not allowed to do in the network, but that's where the state of things are right now. So what I can do right now is show you mock-ups of what the thing is going to look like, assuming that the lawyers are happy with the network. On the left-hand side, we have like an I2B2, a list of medical terminologies that Michelle and others have developed, but then it's enhanced with the biospecimen metadata on the top, as well as Department of Public Health information at the bottom, as well as potentially investigator studies that may have extra levels of approval that are needed before you can embed them in a query. Then users drag and drop these concepts from the left into the query tool on the right. Everything that's within one of the buckets are logically ORed together, and things between buckets are ANDed together. You can have negation and temporal queries in this. So this is queries looking for patients who have a biospecimen of type serum and a COVID positive test result in the registry, but do not have a EHR diagnosis code of type 2 diabetes. So you can mix all these things together. You press the button, it will distribute it out to each of the sites, and it tells you how many patients match those criteria. You get a result that looks something like this, where you're getting counts from the different sites, the number of patients. They're also interested in the counts, the number of specimens. So we might have custom breakdowns related to the information that infectious disease investigators are going to want to know about the different sites. Up at the top, you can see there's a button called My Request. This is where people may say, I would like to create an enclave that has some data sets in there, or I'd want to have a blood specimen mailed to my institution for further analysis on it. And then my data sets, once you have the sets, individual data set links or enclaves available, will be the entry point and how you get to those. Then, of course, there may be automated queries that go to this network. For example, once a week, scanning counts of all infectious diseases and creating spatial temporal visualizations that help the infectious disease researchers and public health users of this track infectious disease over time and identify potential outbreaks or regions where they want to look into more depth on it. The Shrine software that we talked about for the ENACT network and this network underwent a big user interface redevelopment a number of years ago. We had a lot of focus groups, workshops involved in it. People from the symposium were involved in that development. And the use case for that was we called the novice users. So people who had never used these kind of systems before and wanted to get some early insights into the data. So it was a very nice but sort of streamlined, simplified user interface for that. The people who are the first plan users for the MassCPR network are fairly sophisticated. They're epidemiologists, statisticians who are used to temporal visualizations, these kinds of analysis, and are looking for fairly sophisticated kind of queries out of the system. So we had a number of use cases and functional needs for this network, including the ability to plug in third-party visualizations and analyses, support for modifiers, especially for biospecimens, complex temporal queries for infectious disease use cases. They want to know when patients got a vaccine, when they were tested positive in the clinical course of their disease. So complex analyses there. There are standard concepts like a diagnosis or a laboratory test, but more complicated things like computational phenotypes and wastewater, and information is needed to be able to present to users to help them understand what those concepts are. But then also some complicated workflows of requesting data and putting it into enclaves. So as an experiment in the MassCPR network, the Shrine user interface was based off an original I2B2 UI. And I said it had a lot of nice things added to it to make it easier to use and more friendly for the novice users. But we also need some of the original complex I2B2 capabilities for MassCPR. So over the years, I2B2 has looked more and more like the Shrine user interface. And for the MassCPR, we're actually taking the I2B2 user interface and adding back some of that Shrine capabilities to it, so we can have both the nice user interface of Shrine and Shrine capabilities, plus things like the plugin architecture and data set export capabilities that we need within some of the MassCPR use cases. I'll talk more about that, and later today I'm talking about the I2B2 users group and a user interface working group, and in there we're diving into this a lot more, but this is kind of a mock-up of what the I2B2 user interface looks like running a Shrine query where you get multiple results back from each institution. I'll talk a lot more about that later. What I want to end with here is a little bit about governance. What's sort of striking is how the big national network works with 50 institutions, 140 million patients, and how the governance works there. I manage I2B2 at one of the sites that's part of that network, and how the governance discussions work with the MassCPR network. So with MassCPR, we're starting out with 2 hospital systems, Mass General Hospital and Beth-Israel-Lahey. So there's a small local network. And there can't be any voting or disagreement between institutions. Both institutions have to agree to every policy of the network, because if one of them backs out, there's no network. In order to have two no network, we need everyone to agree with it. In the big national network, there's a whole process. There's a smaller committee, there's voting. As long as there's a majority vote, new policies can come into network. Sites have an option of leaving the network at any time, and that's okay because the network is so big that we're not dependent on any individual site. So a site can leave, and there's enough sites, enough patients where we can still have this network. And then often, based on the majority of the sites agreeing to something, then other sites might come on board and agree to those policies as well. And a commercial network, and there's various companies that have built these things out, the company is determining the policies, but they're usually incorporating stakeholder feedback. So they are getting from the academic medical centers, the hospitals, that's guiding a lot of what can be done or not on the network, but the company is, in the end, defining the final policies. With MassCPR, we have a regional network, and this is where things get a bit complicated, where you go beyond 2 sites, and now you're at maybe 6 sites, where as the network starts to grow, you can't get every site to agree to every policy. But there's still certain sites that are big and are somewhat critical. So for example, in the MassCPR network, we have Mass General Brigham and Beth-Israel-Lahey, the first 2 initial sites, and each of those have millions of patients. There are other groups that might have a smaller study. They have 1,000 patients with somewhat different policies, but do you remove the hospital with millions of patients in order to have this study with thousands of patients in there? So it starts getting really complicated how you move from that small network where everyone can approve to it towards the model of a national network where you're having to start to vote in. And that gets that's where we are a bit with MassCPR, with how are we going to scale from the small network to a regional network where we may have to sort of weight different institutions on how important they are to the network and where the policies fit in. So that's a little bit about the technology of MassCPR and where we are in the governance of it, and looking forward to this panel discussion.